Hello everyone. Our project title is Binary to BCD Converter using Verilog. This project has been done by me, Chanika Borgohai, Pallavi Varman, Navajit Chauhan, Subung Saboru, under the supervision of Dr. Biju Goswami sir. So the board we are using is basis tree board, which is an FPGA, that is field programmable gate array. And the software we are using is Vivado 2023 model, which is already available in our AMD website. Now let's come to our binary BCD converter. So this is nothing but it is a process of converting binary numbers into their equivalent BCD representation. BCD is a binary encoded representation of decimal values, where each decimal digit is represented by a fixed number of binary bits. In standard BCD, each decimal digit is represented by 4-bit binary code. So there are different techniques for conversion. It is shift and tree, division based rules, lookup table method, etc. So for according to our convenience and considering the computational complexity, we have found that shift and add tree algorithm is the most efficient one, and we have used that algorithm to convert binary to BCD. Here we have used the switches to denote the binary inputs, and then as you can see the values that are changing, we have used 7-segment display to display the decimal output, and then these LED lights that you are seeing, which are glowing, these LED segments are basically denoting the BCD output. So these are the 8 switches. This is 1 2 3 4 5 6 7 8. We are taking 8-bit binary input. So when we on all the suppose say we input all the ones, 1 1 1 1, we give all 8-bit binary inputs as 1, then the output which we'll be getting as 255, which is a decimal output, and the BCD output would be from LD9. If we consider then it will be 1 0 0 1 0 1 0 1 0 1. So this will be our BCD output. Now let us see how we have interfaced these LED lights and the 7-segment display to the FPGA board. So as you can see here, this is our functional block diagram, and we have used this clock 100 Hz module. So the reason behind using this module is that our basis tree board has an inbuilt 100 megahertz frequency clock. So in that clock frequency, it is very difficult to see any, to display something in our 7-segment display. So we have lowered the refresh rate to 100 hertz. So for 50 hertz it would be it would be high, and the 50 hertz it would be low. So we have used 100 hertz clock frequency, and then we are using 2-bit counter to count the clock cycles, and that is, it would be giving 0 0 0 1 1 0 and 1 1 as an output, which will be eventually act as selector switches and also act as inputs to the decoder. So this decoder outputs, say there are 4 outputs. These are all enable signals, as we have this 4 7-segment display. We are using 4 2:4 decoder, and then this is AN0, AN1, AN2, AN3. These are the enable signals. It determines based on the input, it determines which segment to display. Again, it acts so fast that it is barely visible to note the change in our FPGA board. As you can see, a minimal change you can see here, that if one is blinking, then another is getting dimmed. So likewise the the rate changes. Again, the upper portion, as you can see, the switches act as an input. So these are the binary inputs, and we are using binary to BCD converter. As I've already told you that we are using shift at 3 algorithm. So this algorithm will be discussed by my friend Pallavi in the next video, and the output of this will be giving us ones, tens, hundreds, and so in thousands place we are inputting 4-bit binary zeros. The reason behind it is that to display in the 7-segment display, we only need 3 7-segment displays. So we have put this display off, the thousands display off. So therefore we have input 4-bit binary 0, and then the output of this mux will go to the binary to 7-segment display module. So this will convert the BCD output to 7-segment display, and which will eventually display the decimal output in our 7-segment display. So how we and now let us see how we have displayed the BCD output and through our LED lights. So let us see this schematic diagram. So this is our binary to BCD module. So the output of this will be ones, tens, and hundreds, and these are going. So these outputs are getting connected to the LED lights. So it will be displaying as. So this BCD output will be displayed through our LED lights. So as you can see here in this board. Now let us see a demonstration of a binary value. So let us take a value, a binary input such as 0, 0, 0, 1, 1, 0, 0, 2, 3, 4, 5, 6, 7, 8. So now let us take this binary input. Here this as you can see, we are using 8-bit binary input. So 1, 2, 3, 4, 5, 6, 7, 8. So first one is 0, second one 0, third one 0, fourth is 1, fifth 1, and the last one is 1. So the decimal output is 25, and the BCD output is, if we see from LD9, it would be 0, 0, 0, 0, 1, 0, 0, 1, 0, 1. So this is our binary input, and this is our BCD output. So in this way we calculate the binary to BCD converter through our binary to BCD value through our FPGA board. Thank you.